Here's a sentence you never thought you'd hear. Every year, Santa uses a combination of time dilation and Lorentz contraction to break into billions of homes around the world in a single night. That sounds ridiculous. And it should, because on the face of it, Santa's job is impossible. There are billions of people on Earth. They live on a rotating planet, spread across time zones, with one narrow window called Christmas Eve. Even if Santa spent just 1 second per house, the maths collapses immediately. No sleigh, no reindeer, no logistics company on Earth could make this work. So if we're going to explain Santa without magic, we need something far stranger. And that's where relativity comes in, because the universe has a loophole. When you move fast enough, time itself slows down, and space gets shorter. Not metaphorically, literally. This isn't science fiction, it's what happens when you push speed to its limits. So the question isn't whether Santa can visit the whole world in one night. The real question is, what if, for Santa, the world is smaller, and the night is longer than it looks? To understand how Santa pulls this off, we need one idea. Time does not pass at the same rate for everyone. If you stay still, your clock ticks normally. But if you move fast, really fast, your clock starts to slow down. This is called time dilation. It isn't an illusion, it isn't perception. It's been measured with atomic clocks and satellites. The faster you move, the less time you experience. So when Santa travels between delivery zones in short bursts of extreme speed, something strange happens. From our point of view, minutes pass. But from Santa's point of view, far less time does. He can cross entire continents while experiencing only moments. Not because the night is longer, but because his time is shorter. And that means Santa isn't racing against the clock the way we are. The clock is barely moving at all. But time slowing down is only half the trick. When you move at relativistic speed, space itself starts to behave oddly too. Distances in the direction you're traveling actually shrink. This is called the Lorentz contraction. Again, not a metaphor, not a visual trick, real, measured physics. From Santa's point of view, the faster he moves, the shorter the world becomes. Cities are closer together, continents are compressed, the gap between houses shrinks, the Earth itself becomes slightly squashed. So Santa isn't trying to cross a full-size planet in one night, he's moving through a contracted version of it. A world where the distance between deliveries is reduced and the scale of the problem quietly collapses. Put time dilation and length contraction together and something interesting happens. Santa experiences less time, and the world he has to cross is smaller, which means Christmas Eve stops being impossible and starts being manageable. So what does this actually look like? Santa doesn't fly continuously at extreme speed, circling the planet like a missile. That wouldn't help, and it wouldn't end well. Instead, he moves in short bursts. He accelerates hard, crosses enormous distances in moments, then slows back down, delivers presents, and repeats the process. Relativity does the heavy lifting in between. Those bursts let Santa jump between regions while experiencing very little time himself. And because distances are contracted in his frame, each jump is shorter than it looks. The sleigh only needs to be fast for seconds at a time. The rest of the night is spent at ordinary speeds, doing ordinary things, landing, stopping, dropping gifts. Which also explains something important. Santa doesn't need to start at midnight everywhere at once. He's chasing the night as the Earth rotates beneath him, always just ahead of sunrise, always in darkness. From the ground, it looks like one long night. From Santa's point of view, it's a rapid sequence of jumps and pauses, a perfectly timed dance with a spinning planet. Now at this point, the physics starts shouting. Because yes, accelerating a sleigh to relativistic speeds would involve truly ridiculous amounts of energy. The kind of energy that, if handled badly, would be very noticeable. And by noticeable, I mean catastrophic. This would not be a subtle event. Christmas would be loud. So let's acknowledge that problem, nod respectfully to thermodynamics, and then do what humanity has always done at Christmas. we politely ignore it. Because whatever Santa's doing to solve the energy problem, it clearly works. The planet is still here, the atmosphere is still intact, and the elves are still unionized, which suggests Santa has that part under control. Have you ever noticed how often people talk about seeing shooting stars on Christmas Eve? Brief, silent, gone before you can even make a wish. At relativistic speeds, that's exactly how Santa would appear. Not as a sleigh, not as reindeer, just a sudden streak of light crossing the sky in an instant, and then nothing. Too fast to follow, too fast to photograph, gone before your brain finishes asking what it was. So when someone points up on Christmas Eve and says they saw a shooting star, maybe it wasn't a meteor, maybe it was Santa switching delivery zones, jumping continents, chasing the night. No proof, no measurements, just a quiet possibility the universe leaves open once a year. And maybe that's the nicest part of this whole idea. Not that Santa breaks the laws of physics, but that the universe allows a night like this to exist. A night where time bends, distances shrink, and wonder briefly outruns logic. Whether Santa is real, imagined, or just a clever way of smuggling physics into childhood, the feeling is real. So wherever you are this Christmas, I hope you have a peaceful one, a warm one, and at least one moment that feels a little impossible. And if you enjoyed this, you could make my Christmas by giving the video a like. Merry Christmas from everyone at Dark Beacon, which is literally just me.